G'day, welcome back. We're looking at sum and difference identity questions. Now, a lot of the time when it comes to trigonometry, we need to use little rules to help us solve an equation. And these rules, or these little simplifiers, are called identities. And they're things that we use in trigonometry to be able to reduce something down to a more manageable kind of calculation. We're only going to be looking at sum and difference identities today in terms of cosine, sine, and tan. Now, I've got all these identities up here. I'm going to explain to you what they mean and how they work, but I'm not going to go through a proof for them, okay? You'll understand how they work once you see when you see the pattern of them in the questions. But the things that you need to remember, and the main things you remember is when we have sine A plus B or sine A minus B, we always start up with sine in both cases. And it's always sine A cos B plus, to a sine with a plus in here. And then we just switch the trigonometry ratios. Cos A, sine B. When it comes to sine A minus B, same kind of process. Sine A cos B minus, to match up what's inside the brackets, cos A, sine B, so we switch the ratios. It's when it comes to cos and tan that we actually do the inverse of what's happening in the sine in the brackets. So if we have cos AB, then we have something that looks like this. Cos A, cos B, minus sine A, sine B. So different to sine, they actually group together the coses and sines for A and B. But we notice that the signs are different. So when we have cos A minus B, we have cos A, cos B, opposite sign to what's in the bracket, plus sine A, sine B. And the same thing happens when it comes to tan. So we have tan A plus B. Okay, remember that these A plus B are going to be degrees or radians. So we start off with tan A plus tan B, so these two should match up. And then we find the inverse, 1 minus tan A times tan B. And then when we have tan A minus B, the minus in your numerator matches, so tan A minus tan B, and then it's 1 plus tan A tan B. So they interchange. So these here are rules that we can use to help us solve ratios or solve trigonometric questions. So what I mean is, let's get into a question here. Let's do sine 90 plus theta. When we get a question like this and we're being asked to expand and simplify. So when we're expanding, we're simplifying down to our coordinate points again from those unit circles. So we look here and we go, well, we've got sine, so it's got to be one of these two. We also notice that it's got a plus in the middle, so it has to be this first function. So if I was going to expand this, this would then become sine 90 times by cos theta plus cos 90 times by sine theta. So effectively what we've got here is we've got A and B up here. So those are interchangeable in terms of the ratios. So we've expanded it. So now we have to simplify. Well, sine 90, we look back at the unit circle, sine 90 is up here. And we knew that x was equal to 0 and y was equal to 1. So in this case here, sine 90 is equal to 1. So we will write in here 1 times cos theta plus, well, cos theta, when we look at that unit circle again, remember at 90 degrees or pi on 2, the x coordinate at that point here, which is cos, is 0. So therefore we have 0 times sine theta. If we simplify this up, well, that's going to cancel out. So therefore, our answer is cos theta. Okay, so all is linking it back to that unit circle. So sine 90 plus theta equals cos theta. So let's do a second example. So a second example would be, let's write it out. Let's simplify this. So if we had cos 5x sine, do we want to do sine? We'll do cos 5x cos 3x plus sine 5x sine 3x. Okay, so let's have a look at this here. We want to simplify this down so it looks like one of these first parts. Well, we've got, look at the pattern, we've got cos 5x, cos 3x, sine 5x, sine 3x. Well, where do we have that where the patterns are the same? Well, we have it at cos. So we could say, well, let's identify. Hang on, I've got an A here, I've got an A here. I have a B here, I have a B here. Well, that looks like what we've got here. So we can rewrite this down and say, well, I know it's got to be cos. But what are the values now? Well, A is 5x. And B is 3x. But remember, this here is positive here. So if it's positive, I have to write it as a negative inside. So therefore, cos 5x cos 3x plus sine 5x sine 3x, we can reduce down to cos 5x minus 3x, but because these here are like, I can now get my answer of 2x. So this here will simplify down to 2x. And what these identities do is they make this much easier to understand. So instead of calculating all this when you're multiplying with another expression, I can just say, you know what? This here is exactly the same as writing this. And this is going to be easier to do a calculation with. Let's do one last example. And this time it's going to be a little bit more tricky in terms of the way we calculate it. And we'll look at the tan one. So let's erase this. Actually, we'll come back and we'll look at the tan one next time.